This is a small showcase of our work in chemistry. The aim of the lesson was to help students explore a complex idea but explain it in simple language. So gave them a few options on how they could present their understanding, with the idea that being able to show others, being able to teach material, they would be hopefully better develop a better understanding themselves. So the first technique was using Keynote with animations and audio. Keynote allows students to draw objects, so drawing different atoms, and then choosing to animate different atoms, so they can shift them and show the changing reactions. They can add actions, and then finally they can record a narration over the top of the Keynote. This allows them to explain the processes and analyze the different chemical reactions. So this is a student example.
So when the bond breaks between a carbon and a chlorine, the electrons are more attracted to the chlorine atom because it is more electronegative. There's the reaction will take place. You can see the reaction taking place, and then what you have is a carbocation and a chloride ion. And after this, the AOH comes in and starts to react with the carbocation, and then they lose their charge, and then they combine to produce 2-methylpropan-2-ol.
This is a second example of using video capture, animations and audio. So the kids did a little bit of planning and then used simple whiteboards and the cameras on the iMacs to record their explanation of the idea. This little clip shows the students developing their ideas, and the two of them together are just debating on the best way to show the idea and just correcting their work, getting feedback from the teacher. This is all before they publish the final piece of work, which is just here.
The unimolecular reaction. This shows 2-fluoro-2-methylpropane. Since it is a unimolecular reaction, the RDS occurs in the first step. Now it is showing the carbocation forming and the fluoroanion as well.
So the technique was to record the drawings, put it into iMovie, then speed up the speed of the videos. Then after that is adding their own audio, as you can see from this piece.
Square brackets, and this is simply the F leaving the halogen alkane and the OH entering it. Now what you see here is the production of ethanol, and this is because the OH is bonded instead of the fluorine atom, and this is the substitution reaction.
So the third technique is using the small whiteboards. So the students sort of plan their ideas and how they're going to explain it, and repeatedly drew different ideas. So here they're starting to explain the structure of the atom, and then going through there, taking individual screenshots, putting it together in iMovie, and then putting the audio recording over the top. And it's quite effective in a slightly different way. So here's an example.
Initially, the compound exists in this form. However, there's a rate electronegativity that exists between the fluorine and the carbon atoms. The carbon atom is slightly positive and the fluorine atom is slightly negative due to the differences in electronegativity. This can be illustrated in this manner. As the electronegativity of fluorine is greater than carbon, the two electrons shared are pulled more to the fluorine atom through heterolytic fission. This results in the formation of a carbocation.
As you can see, this technique is pretty straightforward, and I thought for the time in the class was probably the quickest way of them explaining their idea. If you look at the other techniques, I think the animations of the atoms in the Keynote presentation, or the way the student draws the theory and explains at the same time, both powerful in slightly different ways. But it's nice they could express themselves in different ways. And this is just how this group chose to explain their ideas. And other groups did different things as well. So other techniques, it's kind of this idea of a common craft video where they're cutting out animations. This took this group so long to prepare, and they didn't actually pull it together in the end. But the idea is quite simple, and I'll show you an example a bit later. And the other technique was using the interactive whiteboards and just doing screen recording. I think feedback from the teacher and feedback from the kids is that it was a really powerful activity that forced them to learn something that was very tricky and complicated, forced them to explain it in a way that was simple, and over time I think they will remember this, and I think this is a different learning aid for getting a deeper understanding of complex concepts. And I think there's no reason why a similar technique can't be applied in different ways as a good revision tool, something in economics, physics, and anything where students are explaining a complex thing but need to put it into simple language. And that's us.
And then they combine to produce 2 meters.